Hello guys, welcome back to the channel. So today we will start the last contest, that was 1077 dip 2. So we will start with the problem C. So what is the problem C? You are given an array A of length n, an integer k, we call it piggy if and only if it is possible to sort A in non-descending order by performing the following operation an arbitrary number of time. Okay, basically you have given an array of length n. You have to find a value k, and we have to call this value k a piggy. And to call this value piggy, we have to sort array this into non-descending order by performing any number of operations, possibly 0. Okay, so in one operation what we can do, we can select two indices I and j, and the element difference between I and j should be greater than or equals to k. If the condition meet, then we can swap I and j. Okay, so you have to maximize the value k. If the value of k doesn't exist, then you have to return -1. So this is the problem. So basically, to find the value of k, we have to sort this array, okay, and maximize the value k. So let's see in this example 17395. To sort this array, what we have to do, first we have to find out how many elements are disturbed. Okay, so as you can see, the 7, 9 and 5 are disturbed, but because the sorted one is 1, 3, 7, 9 and 5, so 5 and 9. So 3, 7, 5, 9 are disturbed elements. So what we have to do, we have to place this 3 to this position. Okay, so according to the question, what we can do for this, we can only swap. Okay, and the condition of swap is the difference between these two elements should be greater than or equals to k. Okay, so suppose to make this array into this, we have to swap, let's suppose t elements, t pair of elements. Okay, like a1, a2 and a3, a4 and a t and something aq. Okay, so we have to swap these pair of elements. Okay, so to swap these pair of element, we have some difference like k1, k2 and k3. Now our answer should be the minimum of these k's, because if I would take the value greater than the minimum, suppose the value of k is k1 is 2, k2 is 3 and k3 is 5. If I would take the 3, okay, so I cannot swap the pair a1 and a2 because this difference is only k1, that is 2. Okay, so to make this swap, we have to take the minimum value of this. So our answer would be k1 in this scenario. Okay, so this is a general case, like we can see in this example. First we have to swap 3 and 7, so the difference is 4. Okay, now the array would be like this. Now we have to swap 5 and 7, so 1, 3, 5, 7, 9. Okay, so the difference between these two elements, 5 and 7, is 2. So our answer would be 2. Okay, so according to this scenario, we can, if I swap only these pairs like 3 and 7, 5 and 7, then our answer would be 2. Okay, but we have to maximize this value, this 2 we have to maximize. So anyhow, we have to increase the difference between the elements what we are swapping. Like I am swapping 3 and 7. So anyhow, if I make any number, if I will place any number at this position, so that the difference between these two elements would be greater, then it would be beneficial for us. Okay, so likewise we can say if I would increase the difference anyhow between the elements, then it is possible to increase the answer. Okay, so we know the disturbed elements, always we know what are the disturbed elements. Like in this array we have 7, 3, 9 and 5, all are disturbed elements. Okay, so what if, and second thing, what we know to sort this array, I have to place 3 to the position, 5 to the position, 7 to the position. Okay, so can I find any number for this 3? Okay, can I find a number for this 3, so that if I will swap with that number that I will find, then the answer would be maximum? Is there any way to find that number? Let's figure out. If I would find the number that would make the number difference maximum, then it would be better for us. Okay, so for every number, if I find, for every disturbed element, if I able to find the number which would give the maximum difference between these two elements that we are going to swap, then our answer would be maximize. Okay, so for this what we can see, like suppose what we have, this is the array. Okay, so in this array some elements are present in sorted position like 9, 8, and here 7 also. These are unsorted, 5, 3, 4, and 6. Okay, so these are unsorted elements, and 1, 2, 3, 4, 5, 6, 7, 8, 9, and these all are sorted elements. Okay, so we have to find a number for this. What is the number we have to swap with that would create the maximum value of k? Okay, and this number would be present at the position where 3 would be placed. Like in this scenario, in this example scenario, 3 would be placed here. So I have to find a number for 3 which would maximize the difference if I would swap in that number with this 3. Okay, so what we have to do, we have to first find the numbers. Okay, so let's think what is that number. Okay, so this number would be, now there are two scenarios. There are two scenarios. First scenario is, may I eligible to find that number from the numbers that are already sorted, or the second scenario is, may I only allowed to take the numbers which are not in sorted position. Okay, let's suppose if we go with the first scenario, like if I am allowed to take the elements which are already in sorted position, so what would be our number? What would be our number? So our number, like I have to maximize the difference. So what I would take, I would only prefer the first number or the last number, because the difference between the first number and this number, or this number and this number, would be maximum. Okay, so whatever would be the greater number, whatever number, whatever difference would be greater, I would prefer that. Like this would give me 6 and this would give me 2, so I would prefer the number 9. So for 3, I want ki this 9 would be present at the location for which I have to make swap, right? So for what I want 9 would be present on this position. Okay, so for this what I will do, I will swap them, 5 and 9. Okay, so 9 would be present there, 5 would be present there. So here we can make swap between 9 and 3. And this is the maximum difference between these two numbers possible. Likewise, we can do for every number, we can find for every number the maximum difference, possible maximum difference. We have to find every element, we have to find for every element the maximum number. Okay, so for this also, for every number which are not in sorted position. Okay, so in this scenario we have taken the number which is already in the sorted position. So second scenario is saying, why would I am taking this number? Okay, if I would take this number, this would also disturbed. Okay, so for this what I can tell you, if this number is disturbed, like if I by doing this scenario that I have tell you, if I make these numbers sorted, like 2, 8, 3, 4, 5, 6, 7. Suppose 1 and 9 are not sorted, but these all elements are sorted. So we can like 1 and 9, so we can swap them. Simple. So it is feasible to take the numbers which are already in the sorted position, like 1 and 9. So our simple approach has been made. What is this? We have given an array. First we would find what are the disturbed elements. Okay, so suppose these are the disturbed elements, I would find these elements. After that, for every element I have to find the element to which I will swap it. Okay, and after finding that element, I will place the finded element on the position where I want to have the number that I am going to sort now. Okay, so our approach, first find the disturbed element. After finding the disturbed element, we have to figure out the maximum element which we would have to swap it. Okay, so to find that, we will always include the minimum number and maximum number, because if we include minimum and maximum number, then our answer would be maximum. Okay, our answer would be maximum, and we are allowed to do that, because if these numbers are also get disturbed, then we can able to make them at the right position, because only 1 or 2 swaps are required and the difference between these numbers is maximum. Okay, so whatever k we have got from this disturbed element, this k would always be less than the value of k, the value of difference what we required to make first and last element to their position. Okay, so our approach has been made simple, like we have to find the maximum number which we are going to take for swap, and to find this we can include first and last element. I hope everything would be clear. So our simple solution is this. Now one case is remaining, like when the answer would be -1. What is the logic behind the -1? Okay, so question is saying -1 would be when the value of k does not exist. If certain integer doesn't exist, so we have to find out where the k would not exist. So in this scenario, when the array is not in the sorted way, array is not sorted, so in this scenario we always have the value of k. It is a simple approach. You can see that we always have the value of k, because whatever means to make the array sorted we have to swap, and for making swap there is a constraint, the difference would be greater than equals to k. So what would be the minimum difference? We will make the minimum difference equals to k. Then always we have the value k exist for unsorted array. Okay, but for the sorted one, how we can decide the value of k? Because in this scenario we cannot make any operation because array is already sorted. We are not allowed to make any operation, we are prohibited for that. Okay, so we cannot decide what would be the value of k. We can say any value, so we can not make sure that this value would be the k. So in this scenario the answer would be -1. Okay, so let's move on the code part. So I have written the code in the C++ as usual. So first we have taken the input n, and we have made two vectors, vector n and a copy vector. First I have taken the input from of vector and check the array, input array is sorted or not. If the array is sorted, then we would return -1. Okay, after that I would find the disturbed element. So for finding this I have stored this vector in the copy vector and sort our vec. Okay, so now here what I have did, I am finding each vec I is not equals to copy I, means what this element is disturbed or not. If the element is disturbed, then I have inserted that element into our a vector re. Okay, re vector. Okay, so if the element is not disturbed, then we have the scenario the element is not disturbed. So in the case of index 0 and last n-1, we have to include this number also, because it would contribute in the maximizing of the answer, maximize the given value for the answer. Okay, so here we have got the re and we have sorted that re. Okay, so why we have sorted this re value I will tell you, because here suppose I have find out what are the disturbed elements. These are present like 5, 3, 9, 2, 1 and 10. Okay, so if I sort it, then I can easily find out the answer for every number. So what I have did, I am iterating from 0 to end and finding out the answer. So answer would be maximum of current element minus first element, comma last element minus current element. So this would be our answer. Okay, and we have to minimize this answer that I am telling you previously. So this is the answer, and if we are good to go, if you will run that, then we will got the answer. And if you will submit the question code, then it will be accepted. I hope everything would be clear. So if you find anything that I will help you in, then you can comment it out.